Ever wondered how a motor's torque gets calculated? Or what exactly makes a DC machine move? Welcome to the fascinating world of engineering where understanding torque is paramount. When it comes to DC machines, the torque equation takes center stage. It's the mathematical superstar that determines the performance, dictating the power behind our machines. It's the unsung hero, often overlooked, yet vital to the operation of any DC machine. Today, we'll unravel the mystery behind the torque equation of a DC machine. Let's embark on this scientific adventure together. Before we dive into the equation, we need to grasp the basics. What is torque? In the simplest terms, imagine torque as the muscle behind the rotation of an object. It's the force that spins, turns, and twirls things around. Picture yourself opening a door. The effort you exert to swing the door open is, in essence, torque. It's this rotational force that is the lifeblood of motors, from the smallest electric toothbrush to the most powerful industrial machines. The unit of measurement for torque is the Newton meter in the metric system. It's like saying how much twist you can apply to an object at a certain distance from the pivot point. The greater the torque, the greater the object's ability to rotate. Now that we have a basic understanding of torque, we can move on to the core of our discussion. The torque equation of a DC machine. The torque equation of a DC machine might seem complex, but once broken down, it's not as daunting as it appears. So let's take a closer look at the torque equation of a DC machine. This equation is primarily based on the fundamental principle that torque is proportional to the product of the magnetic field, armature current, and the armature length. It can be expressed as T equals K times phi times Ia, where T represents torque, K is a constant, phi is the magnetic field, and Ia is the armature current. But let's not get overwhelmed by these terms. Each plays a crucial role in the functioning of the DC machine. Let's break it down. First, we have T, the torque. Torque is essentially the measure of the force that can cause an object to rotate about an axis. It's what gets the machine moving. Next, we have K, the constant. This constant is a function of the machine's physical characteristics, like the number of poles, the number of armature conductors, and the machine's geometry. Then there's phi, the magnetic field. In a DC machine, this magnetic field is created by the field winding. The strength of this field can be adjusted, which in turn affects the torque. Finally, we have Ia, the armature current. This is the current flowing through the armature winding. The greater the current, the higher the torque. By understanding these terms and how they interact, we can see how the torque equation works. If we increase the magnetic field or the armature current, we increase the torque. If we decrease them, we decrease the torque. Simple as that. The torque equation is a valuable tool. It's not just about understanding how a DC machine works, it's about controlling it. By manipulating the variables in the equation, we can predict and control the performance of the machine. With this understanding, you can now calculate the torque of a DC machine and predict its performance. So next time you come across a DC machine, remember it's not as complex as it seems. It's all about the torque equation. We've covered a lot today, so let's quickly recap the main points. We began by exploring the power behind machines, delving into the concept of torque. Torque essentially is the force that causes rotation. It's the driving force behind every machine movement, from the simplest hand drill to the most complex industrial machinery. We then ventured into the heart of the matter, the torque equation. This equation, T equals F times R, is the mathematical expression that links force, radius, and torque. It's a fundamental principle in engineering that helps us understand and predict how machines will behave under different conditions. So there you have it, the basics of torque and the torque equation. These are not just theoretical concepts, but practical tools that can be applied in real-world situations. Understanding the torque equation is a powerful tool in the field of engineering and can help you excel in your studies and career. Remember, knowledge is power. Until next time, keep exploring and learning.